Hi, my name is Yuri Zuban. I'm a conversational backend developer at Master of Code Global and Glia. And in this video, I will share two applications to automate customer support using Retrieval Augmented Generation or RAG architecture. The first is built using a more custom approach, in that sense that it uses OpenAI embeddings and chat completions API and a vector database Pinecone, which are connected using some custom logic. And the second application is built using the recently announced OpenAI Assistants API, which implements the RAG architecture out of the box. As a bonus, at the end of this video, I will also share the results of some market research and an idea of a product which could be built based on such applications. But before we look closer at our applications, let's quickly remember what RAG essentially is. So the key point of RAG is that when we are sending requests to a large language model, then besides the query itself, in our request we include some additional information based on which the model is asked to respond. For example, here in the OpenAI's playground, I have a system message which instructs the bot that you are an experienced and professional customer service agent of some shop, tasked with kindly responding to customer inquiries. Give the answer in Markdown format, always answer in English, keep your answers concise. And if we ask that if it's possible to return something bought at clearance, then we see that GPT 3.5 Turbo says that yes, you can return an item bought at clearance, etc. That is, this is the best answer it could generate based on its training data. However, this may not be the fact for your specific shop. And if we use this similar system instruction, system message, however, we also add an instruction that the model should respond based on some context, and we provide that context, which in this case sounds like certain items are considered final sale and cannot be returned, etc. And we ask the same question. Then we see that the model responds based on the context and says that I'm sorry, but clearance items are considered final sale and cannot be returned. There are multiple ways to implement this search for contextual data. One of the most popular nowadays is vector databases. OpenAI and other providers have so-called embeddings models. These models allow to generate embeddings vectors for a piece of text. Vector is a long list of floating point numbers, which represents where in the multidimensional space of the model the given text is located. And texts with similar meaning have similar vectors, though they may be written in different words. This allows to look for similar by meaning texts using their vectors. That is, if we populate our vector database with some contexts, then for each incoming visitor's query, we may generate a vector, and using that vector, we may try to fetch relevant contexts. So there are different vector databases. I compared several of them in one of my previous videos. So in this project, I was using Pinecone vector database. This is a paid solution which suits for commercial and production applications. Also, it has a free tier, which is quite enough for such projects. So let's look at our RAG applications. And the first one will be a so-called custom RAG. It will be using vector database Pinecone for storing and searching contexts, and it will be using OpenAI's embeddings and chat completions API. First, we need to populate our vector database with contexts. This step will be different depending on the project or customer we are working with. In case of a real customer, it would be logical to request that information from them. That is, some FAQ pages or documentation or maybe transcripts of their customer support communicating with their visitors. For this dummy application, I copied FAQ from one website and then I rephrased it using helper script. So here it is. That is what this Python script does, is that it connects to a Google spreadsheet using a Google Cloud Project service account key, and then it reads the original texts from that spreadsheet and it rephrases them by rewording and also removing any identifiers such as addresses, numbers, etc. And then it saves the resulting texts to that same spreadsheet but to a different column. Then I also generated possible users' questions using a system prompt like this. So you will be given an article from FAQ of an online shop, generate 3 possible questions, etc. And here is an example. Having those questions and answers, I used another script. Here it is. It imports the needed dependencies. Then again, it connects to a Google spreadsheet using that Google Cloud Service account key. Then it connects to Pinecone, initiates a Pinecone index if that is not there. Here we can define which rows from the Google spreadsheet need to be processed. And then the script just reads questions and answers, combines them. It generates a vector for that text. And finally, it saves the vector together with the original text to Pinecone. One point which needs to be noted, that Pinecone allows to save metadata, and in that metadata we will have the original text with a question and also a special key called data type. And this data type can be knowledge base. And another data type which I used in this project was race to support. That is, I had vectors and documents of 2 types. The first one is knowledge base. These are the contexts to be used for answering visitors' questions. Another type of documents were phrases which the bot needs to interpret as the request to human handover. So we are ready to start our application. But first we need to create a .env file and fill in the needed secrets and configs. We need a PostgreSQL database. In this project I was using Supabase, and here we can find that connection string. Then we need Pinecone environment, API key and index name, which can be found on Pinecone.io dashboard. Similarity search limit and top K can be left as they are. These are the default values used during similarity search. And then we have customer configs. This is an array of objects, and for each customer there are the following required keys. X customer ID. It's the ID of the customer. It's a UUID which needs to be generated once for this customer. X API key is the password for this customer, and these 2 keys need to be sent as headers to that completion endpoint of our application. Then we have OpenAI key and a OpenAI organization for this specific customer. That is, our application can be multi-tenant and support several different customers, each with their own OpenAI credentials. Okay, so we are ready to start our application. First, this is my Supabase database, and as you see, at the moment there are no tables there. I will start my application using npm run start local command, and we see that it established connection to Pinecone, and then it runs migrations, and the application started. After this, we see 3 tables were created on Supabase. That is customers, which is empty, users, and conversations. So all tables are empty. I will run my application in debug mode. Here is my postman request, and we will be making a post request to this complete endpoint. In the headers, I'm passing customer ID, which is that ID which we generated and saved in our environment file for this specific user. Other IDs will be rejected if they are missing in env. Also, there is this password for this specific customer. And in body, we have some random UUID as user ID and actually our query. I bought an item during clearance. Can I return it? So let's run it and see what happens. The main logic is in the controller call in the file OpenAI TS. And first, we generate an embeddings vector for that utterance. Then we do similarity search, and here we see also that vector embedding, and this function get contexts and handover triggers by vector. It returns 2 arrays. The first is documents found in the vector DB which correspond to human handover requests, and we see that no such documents were found. And the second, relevant matches key B, is an array of contextual documents found with similarity above our threshold. And we see that 1 document was found, and it says that, so it has first that user's question, is it possible to return something I bought on clearance in the store? And then a piece of FAQ for this site. Our goal is to process and ship orders quickly once you've and let's see if it has what we need. Please note that last chance or clearance items are final sale and cannot be returned or exchanged. Okay, so what happens next? If handover requests were found, the bot will trigger handover, or in this case it will just write that let me pass you to a live agent. If it's not true, which is this case, then we will go further. We will check if there are no contexts, and in this case our bot will use a special small talk prompt which should handle small talks. However, in this case we have context, so we will go further and we will generate messages for actually contextual question answering, and we see that 2 messages were prepared. One is the system message, and it instructs the bot, so you're an experienced and professional customer service agent, and other instructions. And the other is actually the user's question. And our system prompt here we see generate response based on the following vector context, and here is that context from our vector database. And then we run this get chat completion function, which actually fetches responses from the LLM. And here is our response. I'm sorry, but clearance items are final sale and cannot be returned or exchanged. Here is our postman, which is still waiting. And we also will save this question and the answer to our database. Okay, in Postman we've got this response, and if we check our database, we see that a new customer was created, a new user was created, and in the conversations table we see two records. One is from the user with user's question, and another is from the assistant. It's the bot's response. Let's try running some other questions. For example, let's start a new conversation from a new user, and let's start from some small talk. Hello, I have a question. Okay, let's see. No contexts were found. So then we expect the small talk prompt to be used. Here it is. And let's see what was the response. What is the question? Okay, let's ask something irrelevant. Yet another dialogue. Weather forecast. And in this case, it says that I haven't found relevant info in my knowledge base. Let me pass you to a live agent, which seems also to be correct. One of the challenges which I faced when working on this application is to satisfy two seemingly contradictory requirements. The first one is that the bot should respond only based on the context from the DB. So no customer will want to use a bot which provides some false information. Another requirement is that the bot needs to handle small talk, which might not have any specific context pre-saved in the DB. In my opinion, this can be solved in different ways. One is to construct a special big prompt, which would ask the bot to first differentiate whether the question is a small talk or it's a question about the company or it's a non-relevant question, and respond based on that. Such prompt becomes big, and LLMs tend to, so to say, pay more attention to the beginning of the prompt, so chances increase that that prompt may not be followed in full. Alternative approach, which I actually used in this application, is to route between different smaller specialized prompts based on the results of the similarity search. That is, once again, what is happening in my application. For each user's input, we try to find contexts in our vector database. And if one category of contexts documents is found, which are handover requests, then the bot triggers handover. Then, otherwise, we check if any knowledge-based contexts were found. If none, then a special small talk prompt is used, and the bot handles small talk, asks the user to provide more information, so on. If relevant knowledge-based contexts were found, then another prompt is used, so to say, question answering prompt, and the bot tries to respond based on that context. Okay, so now it's time to look at our second application, which was built using the recently announced OpenAI Assistants API. When OpenAI released this feature on OpenAI Dev Day on November 6, 2023, it sounded like they are kicking off from the market all of the developers of custom RAG-based products together with vector database platforms, etc. Because now, instead of all that manual parsing of contexts and adding them to the vector database, which we did earlier, and handling the similarity search, it was all abstracted and happened automatically. All what is needed when working with OpenAI Assistants is to upload a file using UI or API call, and then create an assistant again using UI or API, having passed the ID of the file or files uploaded. And that's actually what we need for our second application, and let's see how it's done. Let's create a new assistant using OpenAI's UI. I'm in Playground. I will switch to Assistants, and here is the list of my assistants. I already have one. Let's create another one. For that, I will click Create, add a name for our assistant. Let's say it will be AI24 Support UI. Then Instructions, and here I will use that system prompt which was used in my previous application, which says that you're an experienced and professional customer support agent of some shop, and some other instructions go further. Then I will choose a model, and let's say that for this I would choose 3.5 Turbo 1106. Then we need this retrieval function, which is actually a retrieval augmented generation feature. And then we need to add a file, and I will find this file which looks like this. It has example questions from visitors and expected responses from the agents. And that's it. I will click Save, and we have a new assistant created. We will need this ID. Alternatively, we can create an assistant programmatically. And this repository, AI24 Support OpenAI Assistants API, in the folder scripts has a file called create OpenAI Assistant.js. And what it does is it uses OpenAI package to read a file from our local computer and to upload it to OpenAI. Thus we get file ID, and then it creates an assistant using the assistant name, and let's say it will be AI24 Support API. It defines the model, defines the instructions, and we indicate that we need a tool of type retrieval, and we are passing one, in our case, one file ID here. We need to add our correct OpenAI API key here, and let's see how it works. Here we see that the file was uploaded and it got this file ID, and then an assistant was created and it got this ID. Let's see here. And really, we got this third assistant called AI24 Support API. For our application, we will need this ID. To run this application, we need to set up it similarly to the previous one. Here is an .n.example file, which shows what secrets and configs are needed. Again, we need a connection string to connect to a PostgreSQL database, and I will be using Supabase for that. And as in the previous application, we need the following configs for each customer: X customer ID, which is a UUID for the customer, X API key, a password for this specific customer, OpenAI API key for this customer, OpenAI organization name, and here we have this new key, OpenAI Assistants Assistant ID, which is an ID of the assistant which we just created. I will start my application. We will start without any tables in our database. Once the app starts, we expect 4 new tables to be created. So it started on port 3000, and here we have tables: customers, users, conversations, and threads. All of them are empty at the moment. I will run my app in debug mode. So here in Postman, we will be triggering endpoint assistant complete, passing user ID, some random UUID, our question, And in the headers, we will have that customer ID, which was saved in the environment file, and this API key for this customer. The main logic is in this OpenAI TS controller file. And here, first, a customer will be saved to the database if it doesn't exist. Then we will search for a user and a thread in the database. If they are not found, which is this case, a thread will be created on OpenAI. And after that, we will save the user and the thread to the database. So we've got a thread ID, then a message will be added to that thread, and then we will create a run, which means that we will run our assistant on that thread with a newly added message, and we will be polling for the run completion. And once the run hopefully is completed successfully, we will list messages from the thread. So it's still waiting. We will list messages, and we will take the last message. We will do some checks, as we need this message to be from the assistant, and we will return it to Postman, having saved our conversation to the database. So it's still waiting. So, and our run failed. Okay, let's try once again, maybe for a different user. And finally, our run succeeded. So let's see what messages we got. This thread has two messages. The first one is our question, can I return item bought at clearance? And it's a message from the user. And the second one is the response from the assistant, which says that no items bought on clearance cannot be returned. And here is this answer. So let's also test our app with other utterances. For example, let's see how it handles small talk. It takes longer today for the API to respond. So it says, certainly, please go ahead and let me know what the problem is, and I'll do my best to help you. Okay, let's ask something like, what will be the weather and it says that I'm sorry, but I couldn't find the weather information for New York in the document you provided. If you have access to internet, do that yourself. Okay, so we looked at two applications built based on the RAG architecture. One is using OpenAI embeddings and completion endpoint, plus a Pinecone as the vector database. Another uses OpenAI Assistants API, which has a RAG approach implemented out of the box. In order to check how accurate or inaccurate these systems are, I created a simple testing framework. It consisted of a Google spreadsheet where the questions were written, and also expected responses are the texts with which I will be comparing the bot's responses. And then there was this script which is in the AI support 24 support OpenAI Pinecone RAG repository, and the script reads questions from that Google spreadsheet, and then it sends those questions to the local application, and it saves the received responses to a separate column. And then I manually compared the expected response and the actual response and marked them as correct, incorrect, or partially correct. And this was done for both that custom RAG application, which we looked at the beginning, and with the app built using Assistants API. There were around 60 questions. The questions were divided into 3 categories. The first one, which is called here exact matches, are questions which have responses in the vector database or in the context document. And the questions exactly match the questions saved in the context. The second group, rewarded matches. These questions also have an answer in the vector database or the document. However, the question itself is formulated in a different way than it's saved in that context database. And the third category, small talks, are actually small talks like greetings and also irrelevant questions to which the bot should not respond. For example, like, what's the weather tomorrow? And the results were the following. For exact matches, the custom reg, out of 26 questions, it correctly responded to 25, and one response was partially correct. That is, the ratio of correct responses was close to 100%, 96. In case of Assistants API, out of 26 questions, only 15 were answered correctly, 5 were answered partially correctly, and 20 responses were incorrect, which gives us around 58% of correct responses. Rewarded matches, that is, questions with answers in the context, but formulated in the way which is new for the bot. Out of 25 questions, custom reg responded correctly to 14, and Assistants API reg is responded correctly to 10, which gives us 56 and 40% correspondingly. And in case of small talks, there were 5 such questions. Custom reg responded to 60% correctly, and the app based on Assistants API handled 80% of such questions correctly. If to sum up all the 3 categories, the percentage of correct responses was 75 or 3/4 in case of the custom reg and around 52% in case of Assistants API. So general observations are that the app using Assistants API hallucinated more often, and also it more often complained that it failed to find the proper answer in the documents. Potentially, this could be explained by that fact that in case of custom reg application, I was using temperature config equal to 0, which should force LLM to avoid extra imagination or hallucination or variations in its responses. In case of Assistants API, as of November 2023, it doesn't allow to configure temperature or other parameters of the requests sent to LLM, and I assume that the default value of temperature might be higher than 0. Some key conclusions from this comparison are that OpenAI Assistants API significantly simplified the creation of RAG applications. In this comparison, the assistant using Assistants API was less accurate than the so-called custom RAG, possibly because it used temperature above 0 in the requests sent to LLM. Also, RAG assistants based on the Assistants API may be more expensive because, as it's written in the documentation, they may be sending all the context in each request if the context document is not big. But also it needs to be noted that OpenAI Assistants API is only in beta and will be evolving further. Okay, so for those of you who were patient enough and watched till this moment, let me please share some market research and an idea of a product which could be built based on it. I will share a link to this document under the video, but the key points are that customer support automation is a real problem, then this market is quite big and it is still growing, though there are some existing and quite successful products in this direction. For example, Chatbase, which allows creating of a chatbot based on your documents. However, there are still quite many free niches there. For example, one could be building applications customized for specific customers and their specific needs. Another observation is that most of such RAG systems are built around this setup where visitor isn't interacting with a chatbot directly. An alternative approach is when the visitor interacts with an agent and an agent is getting suggestions from a chatbot. An example of a platform where such an agent assistant could be built is the marketplace of applications of live chat customer support platform. According to these statistics, live chat occupies around 5.5% of global market of customer support services, with more than 80,000 customers. Here, how this product could look like in terms of UI. That is, each customer's utterance is sent to our RAG application, and if it's able to find a relevant response, it's suggested to the agent. The agent is able to send this response either as is or after manual editing. Also, agents could save new responses if they were not found by the bot. Integration with live chat allows to use existing conversations as contexts and also add new conversations to our retrieval system. Okay, that's it for this video. Hopefully it was useful for you. Please feel free to leave your questions in the comments and see you in the next video.